Hi, I'm Paul Kyogan from GK Tuition, and in this video I want to talk to you about complex numbers. Now the question that I've chosen to go through here is 2019 Paper 1 Question 2 Part A. In the first part of this question we're told that Z1 is the complex number 2 plus I, and that Z1 has been plotted on the Argand grid. Now you need to realise that an Argand diagram like this, it looks a lot like an X and a Y axis, it's just slightly different. Instead of the horizontal line representing the X axis, it represents the real numbers. So whatever the real number is, it's along the horizontal line. Whatever is along the vertical line, instead of this being the Y axis, it's the imaginary axis. So if you look at Z1, the real number is 2, so that means we go over to 2, and the imaginary number is 1i. So we go up to 1. It's the exact same as if you were plotting the point 2, 1 on a normal coordinate plane. If the x is 2 and the y is 1, it's the same principle. You're plotting the point 2, 1, or in this case, the real is 2, the imaginary is 1. Now the first part of the question asks you to find Z2 and plot Z2. You need to realize that, and they've told you Z2 is 2 times Z1. So that's relatively straightforward. That means it's 2 times Z1, which is 2 plus 1. So all I need to do is multiply this out. 2 times 2 is 4. 2 times I is 2i. So you know that Z2 is equal to 4 plus 2i. Obviously that is part of your answer because it asked you to find that. And now we need to plot it. So my real number is 4, so that means I'm going over to 4. And then my imaginary number is 2, so that means I'm going up to 2. So it's 4 and then 2, which is here. It's the same as if you were plotting the point 4, 2 on a coordinate grid. So real is 4, imaginary is 2, so that means that this point here is the point Z2. In A part 2, we're asked to find the conjugate of Z1, and then we're asked to plot and label it on the Argand diagram. So Z1 is 2 plus I, and in order to get the conjugate, it's the exact same, you just change the sign in front of the imaginary number. So instead of Z1 is 2 plus I, the conjugate of Z1 is 2 minus I. So literally all I do is I change the sign in front of the I. And once I have this, I now want to plot it. So the real number is 2, the imaginary minus I, that's obviously minus 1i. So the real is 2, the imaginary is minus 1. That means that this is where I would plot it. It's the same as if you had a coordinate grid, it's as if you're plotting the point 2 minus 1. But obviously you can't write that down, you have to write it as 2 minus I. And we also have to label this is the conjugate of Z1. In A part 3, we're asked to investigate if the modulus of Z2 is equal to the modulus of Z1 plus the conjugate of Z1. So we can't do all of this at once, so what I'm going to do first is just simplify out the left hand side. These lines mean find the modulus of Z2. And you should know that in order to get the modulus of a complex number, it's the square root of a squared plus b squared, where a refers to the number, the real number at the start, and b refers to the number in front of the I. We've worked out previously that Z2 is 4 plus 2i. So in order to get the modulus of Z2, I just need to sub into this formula. In this case, instead of a squared, it's going to become a 4 to be squared. And instead of a b squared, in this case, it's going to become 2 to be squared. So just notice there, obviously, the first number is the a, the second number is the b. If I get that 4 multiplied by 4 is 16, and 2 multiplied by 2 is 4. So this is 16 plus 4, which means the modulus of Z2 works out as the square root of 20. So that's the left-hand side simplified fully. Now what I need to do is try and simplify the right-hand side. So let's start off here. First of all, we know from the start of the question that Z1 is equal to 2 plus I. Now, Z1 with the line above it, that refers to the conjugate of Z1. To get the conjugate of a complex number, you change the sign in front of the I. So if Z1 is 2 plus 1i, then Z1 is 2 minus 1i. So all it is basically is, instead of a plus, I'm taking it as a minus. So Z1 is 2 plus I, and the conjugate of Z1 is 2 minus I. So to simplify the right hand side, the first thing we need to do is add Z1 and the conjugate of Z1. So z1 plus the conjugate of z1 is obviously, in this case, that just means 2 plus I, which is z1, plus the conjugate, which is 2 minus I. So I just need to add both of those together. And if I add them now, I just need to group the like terms. 2 plus 2 is 4, and plus I minus I cancel each other out. Which means, simplified fully, z1 plus the conjugate of z1 is equal to 4. Now that we have that, we now need to work out the modulus of what that is. So in order to get the modulus, we need to write it in the form of a complex number. So it's easier to write this as 4 plus 0i. And in order to get its modulus, I'm now just going to sub into this formula. So let's just continue on from here. So in order to simplify this, I know that z1 plus the conjugate of z1 works out as 4 plus 0i. And the lines around it here mean that we need to get the modulus of that. To find the modulus of 4 plus 0i, it's the square root of 4 squared plus 0 squared. If you plug that into your calculator, it works out as 4. So the right hand side simplified fully is 4. The left hand side simplified fully, we worked out previously, is the square root of 20. We were asked to investigate if the left is equal to the right. In other words, we're asked to investigate if the square root of 20 is equal to 4. And clearly that's not true. The square root of 20 is not equal to 4. They're different numbers. You could plug that into your calculator and it works out larger than 4. So I could say that the modulus of z1 is not equal to the modulus of z1 plus its conjugate. And so in that case, you put an x through it and your conclusion should be that it's false. Okay, in question 2 part B, we're given the quadratic z squared minus 4z plus 5 equals 0. And we're asked to show that z1 is a solution of this quadratic. In order to prove that z1 is a solution, we need to sub it in. And when we sub it in, we should end up with a 0 on the left equals a 0 on the right. In other words, I just rewrite this equation, except instead of a z, I plug in 2 plus I. So it becomes 2 plus I squared minus 4 times 2 plus I plus 5 equals 0. Now you just have to be cautious here. This is 2 plus I squared, which is 2 plus I multiplied by 2 plus I. Minus 4 by 2 gives me minus 8. Minus 4 by plus I gives me minus 4i, and then I've got a plus 5 at the end. In order to multiply out double brackets, it's the first thing in the first bracket by the second bracket, the second thing in the first bracket by the second bracket. And this bit at the end, I add minus 8 plus 5 and I get minus 3. If you multiply this out, you get 2 by 2 is 4, 2 by I is 2i, I by 2 is 2i, and I multiplied by I is I squared. And then my last two terms don't change. In this case, all I did on the next line was I'm grouping my i's together and I'm grouping my numbers together. I have a 4 over here and I have a minus 3 over here, so I put them together. Then I have an I squared, and then 2i plus 2i is 4i, and I have a minus 4i. Now clearly at this stage, the plus 4 and the minus 4 cancel each other out. 4 minus 3 is 1. And remember, when we're dealing with complex numbers, I squared is equal to minus 1. So I just sub it in and I have 1 minus 1 equals 0. So clearly there, 0 is equal to 0. That's true. And you have to make a conclusion here. So you say, right, we're after proving that Z is a solution. Or in other words, we've shown what we were asked to show. Okay, so I hope all of that video makes sense. If you're struggling with any of that, or you need me to explain it differently, just let me know in class or send me an email and I'll get in contact with you.